Hello, welcome to Honors Pre-Calculus. Today what we will be covering is operation with matrices. We started matrices the other day. We're going to continue talking about matrices for pretty much the rest of the chapter. What we're going to cover in this section is we are going to cover when two matrices are equal. We're going to add and subtract matrices, multiply matrices by scalars, multiply two matrices by each other, and then use matrix operations to model and solve real-life problems. So the first thing I want to do a real quick review on what a matrix is. It's an array of numbers. We use uppercase letters to represent a matrix. So in this case, this is matrix A. That's the uppercase letter. Each element in the matrix is labeled by its row and its column. So element 3, 2 would be the element in row 3, column 2. Remember, it goes rows across, and then columns are up and down. So to name an element, I need to know which row and which column it's in. Remember, to name the order of the matrix, I do rows by columns. So if I have this matrix, it's a 2 by 2, which means it's a square matrix. This is also a 2 by 2. In order for two matrices to be equal, they have to have the same order. In other words, they have to be both 2 by 2s, 3 by 3s, 3 by 1s, whatever. They have to have the same number of rows and then the same number of columns. In order for these two matrices to be equal, that means that the elements in the first matrix and row 1, column 1 has to equal the same element that's in row 1, column 1 in the second matrix. So A, 1, 1 would have to equal -3. The element in row 2, column 1 would then have to equal +7. The element in row 1, column 2 would have to be 7, and the element in row 2, column 2 would have to be a 13. That would make those two matrices equal. So if I had something like, we'll do simple 1, 2, 3, 4, and I want to say that was equal to x plus 1, 2, x, or we'll say y minus 3, 4. In order for these two matrices to be equal, that means that this element in row 1, column 1 has to be equal to this element in row 1, column 1. So 1 has to equal x plus 1. So to solve for x, x would equal 0. Similarly, if I had row 2, column 1, row 2, column 1, 3 would have to equal y minus 3. So 6 would equal y. Yeah, and then notice that the 2 is equal to the 2, the 4 is equal to the 4. That's what makes those two matrices equal. If I want to add two matrices, in order to add or subtract two matrices, they have to have the same order. If you're trying to add two matrices that aren't the same order, then it's undefined. Because in order to add, you add element row 1, column 1 with row 1, column 1. So when I add these, I add the 4 plus the 2, and I get 6. I add the -1 plus the -1, and I get -2. Row 2, column 1, I have the 2 plus the 0, and that is 2. And then finally, I have the -3 plus the +6, and that would be +3. That's how I add. If I had a matrix that was like, except for 1, 2, 3, 4, and I was trying to add it to this one that's a 1 by 2, I cannot add 1 to 1 because this is element 1, 1, this is element 1, 1, but there isn't a 2, 1. They don't match. You can't do it. Undefined. Not possible. Because again, to refresh, this is a 2 by 2, this is a 1 by 2, the order is not the same. So if you want to stop the video, pause for a second, and add these. So you're pausing the video, doing the problems. Okay, welcome back. This should be 2, -3, 1, and then this one you should say is undefined. because here I have a 3 by 3, here I have a 3 by 2. The order is different, and it's not possible to add those two matrices. Okay, next type of multiplication is what's called scalar multiplication. A scalar multiplication is when you have a number outside the matrix, and what you're going to do is you're going to make that matrix 3 times larger in this case, which means that every element has to be multiplied by 3. So it's kind of like doing the distributive property. That 3 has to be multiplied by everything inside the matrix. So when I do that, I'll have 3, 9, negative 6, 18, 24, and 0. That is all scalar multiplication does, is you multiply every single element by whatever the scalar is. Okay, so that was scalar multiplication. Next, we're going to go over the properties of matrix addition and scalar multiplication. Basically, the same properties that you have for regular addition and subtraction hold true. So I can add two matrices, A plus B, or I can change the orders when I'm adding it and add B plus A. I'm still going to get the same sum. So that's the associative property. The commutative property says that I can add B plus C first, then add A, or I can add A plus B first and then add C. Remember, to do all this addition, they have to be the same order. They cannot be different order. They have to be the same size matrix. I can, C and D are scalars, so I can multiply C times D and then multiply it by the matrix, or I can multiply the matrix by D first and then multiply it by C. I'm still going to get the same answer. If I take 1 times in any matrix, I'm going to end up back with my exact same matrix. That's the identity property. And then this would be, if I have a scalar and I'm adding two matrices, I can multiply each one of those matrices by the scalar first, then add, or I can add them first and then multiply. Either way, I'm going to get the same thing. So that's the distributive property. And this is saying the same thing. If I have C plus D and I want to multiply it by A, I can multiply C times A and then multiply D times A and then add the same. And again, it's kind of the reverse distributive property. So those properties all hold true. The one property that's not listed here that does not hold true is when I start to multiply matrices, which is going to be the very next slide. If I take A times B, that is not going to be the same as B times A. I should write that over here, so I will. So that is not the same as B times A. That is not equal. Not equal. Not equal. Does not equal each other. Okay, moving on. So here, when I go to when I solve for two matrices, I want to take 2x minus 2 times the matrix A, and I want to get B as my answer. So in order to add or subtract, the matrices have to be the same. So I want 2 times some matrix minus 2 times A and I want it to equal B. So the way I like to think of this is I'm trying to find the elements that go in here in this one matrix. I want to try and find these elements. But what I'm going to do in order to solve this, I'm going to just leave this as an X because it's going to be easier for me to write this because that's the matrix X that I'm looking for. I want to take this over to the other side, like I would solve any type of equation. So I'm going to have -4, -8, -2, 0, 14, -6. And now I'm going to add 2 times this matrix, 3, 2, 0, -4, and 1. I'm going to add those two. So when I do that, I'm going to distribute my 2. And when I'm talking about distributing my 2, I'm talking about distributing this 2, this scalar multiply. I'm going to multiply everything inside this matrix by that 2. That looks very messy. Sorry about that. So when I multiply everything in this matrix by 2, I'm going to have 0, 6, 4, 0, -8, -2. Now I'm going to add these two together. So I'm going to take negative, remember, add element by element. So I'm going to add -4 to 0 and get -4. -8 plus 6 and get -2. -2 plus 4 and get 2. 0 plus 0 is 0. 14 plus -8 is a positive 6. -6 plus a -2 would be -8. So I have 2 times some matrix is equal to this matrix. Well, I want to handle that too. So if I had like 2x was equal to, let's say, 16, you would probably divide both sides by 2 and say x is equal to 8. Well, the problem with matrices is they can't really divide. So if I had that same problem, 2x is equal to 16, if I'm not allowed to divide and handle that, I would probably decide to multiply by 1/2 because I can multiply with matrices. So if I multiply this side by 1/2, I'm going to get x is equal to 8. So it's the same result, just a different way about thinking of it. So when I want to find this matrix, to get rid of this 2, I'm going to multiply by 1/2, which now becomes a scalar. So I'm doing scalar multiplication. If I multiply the left side by 1/2, I have to multiply the right side by 1/2. And when I distribute that 1/2 to, again, every element in that matrix, I'm going to have -2, -1, 1, 0, 3, and -4. And that is going to be what x is equal to, my matrix x. So that's one way you could do it. Some people prefer that when they're up here, at the very beginning, they like to solve that first. So what they do is they say, well, 2x, I'm solving for x, 2x is equal to b plus 2a. And then I'm going to divide everything by 2, because here I could divide by 2. So I'm going to have x is equal to 1/2 times matrix b plus a. And if you do that, you're going to get the exact same answer that we just got. Either way is fine. It's a personal preference. Just show me what you're doing. Okay, now we're going to multiply matrices. Remember, up until this point, we said to add, subtract, we had to have the same order. So this was a 3×2, this was a 3×2, and that's why we could add and subtract. When I go to multiply, that's not going to be the case anymore. When I multiply, if I have a 3×2, I can multiply that by a 2 by, let's say, 4. In order to do multiplication for matrices, what has to happen is these two have to match. So if I multiply those two, and you'll see when we do it in a second, then I'm going to get an answer that's a 3×4, and that answer comes from what's left outside. These two have to match in order to do it, and then the outside becomes my new dimension. So if this were A, and this is matrix B, I could multiply A times B. I could multiply AB, and when I multiplied AB, I would have a matrix that was in the order of 3×4. If I were to change the order and try and do B times A, if I would try to do that, B, remember, is a 2×4. A is a 3×2. These two numbers do not match. If they do not match, it is not possible to multiply those matrices. So commutative property, or changing the order for multiplication, does not work in matrices. They have to be in a certain order to get a certain product. So I can multiply A times B, that's defined. I cannot multiply B times A, that is not possible, it is undefined. So let me show you why that works. And so we'll do a very simple one. So I'm going to try and find the product. I have A here is a 3×2, and I'm multiplying it by B, which is a 2×2. These two match, so that means that I can do it. I can multiply it. When I multiply A times B, I'm expecting my answer to be a 3×2, which is what is left out here. And it's a good habit to get into the right order, so you know, first of all, that you can do it, and second of all, you know what you're looking for. You know where those answers are going to go. So the best way to do it is to be very systematic and do the same procedure every single time. So in order to multiply, what you're basically doing is you're going to find, you're going to multiply row 1 times column 1. And that's why those two dimensions have to match. So when I do that, I'm writing myself a note because I like to write myself notes. I'm doing row 1, column 1, and I'm going to take -1 times a +1, because that's row 1, column 1 times row 1, column 1, plus, and now I'm going to take row 1, column 2 times row 2, column 1, 0. So I took -1 times the 1, and I took the 4 times the 0. And that's why those two dimensions have to match. So I'm going to have -1 plus 0, and that's going to be -1. If I'm keeping track of my answers, if I wrote myself a note over here, row 1, column 1 is going to be this -1. So in row 1, column 1, I'm going to write a -1. So I multiplied row 1 times column 1. So I'm going to stick with my rows. And now I'm going to multiply row 1 again. But I've already multiplied it by column 1, so it should make sense to you that now we're going to multiply it by column 2. So I'm going to go, so I'm writing myself in my notes. And I'm taking row 1 times column 2. I'm going to take the -1 times the -2 plus, and now I'm going to have the 4 times, and then row 2, column 2 would be 7. So this will be +2 plus 28, and now give me 30. Again, this answer is going to go in row 1, column 2. Row 1, column 2, and that answer is +30. So now I've multiplied row 1 by every single column that I have. So now what I'm going to do, I'm going to erase these for a second so I have a clean slate. And I am going to now, I've handled row 1, so now I'm going to start with row 2. So I'm going to take row 2 and I'm going to multiply it by column 1. Writing myself a note. And we can switch colors. I'm going to do row 2 times column 1. So I'm going to take this 2 times this +1. Then I'm going to take this 0 and multiply it by this 0. I take 2 times 1 and get 2 plus 0, and this is 2. This answer should go in row 2, column 1. So that answer is going to be a 2. Now I've done row 2 times column 1, so now I'm going to do row 2, and now I'm going to multiply that by column 2. So now I'm going to focus on these numbers over here. When I do that, row 2 times column 2, I'm going to have 2. That 2 times now that -2. Plus this 0 times this +7. So I'm going to have -4 plus 0, which will be -4. That answer goes in row 2, column 2. And that answer is a -4. So now I've multiplied this row by every single column. So now I'm going to shift down to the last row. So I'm multiplying row 3, and I'm going to multiply it by column 1. I like the highlighter. So I'm doing the highlighting, and now so row 3 times column 1. So I'm going to take this +1 times this +1 plus this +2 times this 0. And I'm going to have 1 plus 0, and I'm going to get 1. This answer is going to go in row 3, column 1, and that's +1. Now I'm still stick with row 3, but now I need to take care of column 2. So I am going to do row 3, column 2. So I'm going to have that +1 times that -2 plus that +2 times that +7. So you have -2 plus 14, which will be 12. That answer goes in row 3, column 2, +12. And I'm done. I've handled every single row, multiplied by every single column. This is my answer, which is a 3 by 2, and that checks with what I was expecting. It's better to write this first, though. Okay, let's try another one. So I have these two matrices. I have A, which is a 1 by 3, and I have B, which is a 3 by 2. Checking it, I see that I can do this multiplying of matrices. But my answer is going to be different from either original equation, either original matrix. My answer is going to be a 1 by 2. So pause the video, work it out, take row 1 times column 1, take row 1 times column 2, and see what your answer is. So I'll give you a second, you're pausing the video. Okay, welcome back. I hope you check with each other. The correct answer should have been positive 15, negative 15. And again, this answer is a 1 by 2, which is what I was expecting, a 1 by 2. All right, I hope this helps. Your homework, I want you to go back and do some of the problems with the reduced row echelon. So that's going to be on page 582. And then I want you to do the homework on this section, which is page 597, just a few problems. And if you have any questions, email me. Have a great day. Thanks. Bye.